Hi, my name is Jason Sekanina. I'm a design engineer for micromodule power products for linear technology. Today I'd like to introduce you to the LTM4641 step-down micromodule regulator designed to power and protect high-value loads such as FPGAs, ASICs, and microprocessors from electrical and thermal faults. Consider what would happen in the event of a short circuit between the input source and the output node, for example, due to a failed high-side MOSFET. The load becomes exposed to the input source, resulting in a catastrophic load failure and often destroying evidence needed to determine root cause analysis and implement corrective action. Furthermore, system recovery from such a fault is not possible without human intervention. Systems operating in rugged or remote locations with high uptime requirements may want to consider having this extra level of protection that the LTM4641 can provide. We're going to see the LTM4641 respond to such a fault on the DC1543 demo board in just a moment. But first, what sets the LTM4641 apart from other step-down regulators is the extensive protection features which provide a level of insurance against electrical and thermal faults for high-value loads such as ASICs, FPGAs, and microprocessors. At the heart of the LTM4641 is a parallelable, non-isolated step-down switching converter, power MOSFETs, a power inductor, and a high-performance, constant on-time, valley current mode control IC. The LTM4641 accepts an input supply between 4.5 to 38 volts to deliver a regulated output voltage adjustable between 0.6 to 6 volts at up to 10 amps. The output voltage is remotely sensed by a true differential sense op-amp, which facilitates rejection of common mode and differential mode noise in harsh environments while maintaining plus or minus 1.5% total DC regulation error over temperature. The LTM4641 is able to prevent damage from an output overvoltage fault with a response time of less than 500 nanoseconds maximum over temperature, disconnecting the input supply and shorting the output to ground. Now let's go to the lab. As you can see here, we currently have the LTM4641 operating from a 38 volt input voltage, delivering 1 volt output at 10 amps. The channels that we're observing are channel 1, output voltage, and channel 2, the crowbar output, which pulls the output voltage to ground when logic high. Now, we'll create a short circuit between the input pin V and H and the switch node pin of the module. As you can see, the 1 volt nominal output voltage rises to 1.2 volts and then subsides as the LTM4641 initiates its protection features, pulling the output voltage rail to ground, stopping operation, and disconnecting the input supply. After the LTM4641 latches off, operation resumes after the latch pin is pulled logic high. Alternatively, the LTM4641 can be configured for timed autonomous restart with a timer cap and latch held logic high. The LTM4641 includes a second voltage reference to ensure the protection trigger thresholds are still accurate, within plus or minus 2.5% or better, even if the output voltage regulation reference becomes defective. And most of the trigger voltage thresholds are user adjustable with an external resistor. Internal module temperature can be observed at the temp analog indicator pin, and overtemperature response can be configured for latchoff or hysteretic restart. Here's a brief summary of all the LTM4641 protection features above and beyond the thermal and output overcurrent protection found in most switchers today. The LTM4641 ceases operation if any of these protection thresholds are triggered, and depending on the parameter, will automatically restart once the fault has cleared or require a logic level signal to resume normal operation. Specifics on how the LTM4641 responds to each fault condition or a combination of simultaneous faults are detailed in the datasheet. This LTM4641 is a highly compact 38 volt 10 amp step-down converter supporting the power and protection requirements for today's most advanced digital logic ICs operating in high uptime systems. For datasheet download and more information, please visit us at linear.com.